Today we're doing probability, which is the last section that we need to do for your exam. Let's go through these questions. So number one, order the following terms from most likely to least likely to occur. When we think of a probability scale, we have the extremes as being certain to happen, and the other end of the scale is that it's impossible. Another word for impossible is that it is unable to occur. So from most likely, we're going to have certain at the top of the list, and we're going to have unable to occur at the bottom of the list. And all the rest of them are going to fit in between. So we've used those ones up. Now we have to work out the middle. In the center of our scale is an even chance, or another word for even chance is a fair chance, which is this one here. But is there anything that is more likely than that to happen? Yes, there is. It is this one, more than likely. So we need more than likely next. Then we're going to have fair chance. And that just leaves, if I cross out the ones I've used, it leaves these last three: possible, unlikely, and improbable. And we need to put those in order from most likely to least likely. So this is pretty tricky because they all have a very similar meaning, but it should be possible, unlikely, and then improbable. Okay, let's move on. Question 2. Describe each of the following events as being definite, likely, even chance, unlikely, or impossible. So if we are selecting a red card from a standard deck, remember that a pack of cards only has red and black cards, and there's half of each. So that means that that would be an even chance of getting a red card. If we go down to part E, how would we describe the probability that it will rain at least once during the next month? It's definitely not certain that it would happen, but I hope that it is pretty likely that it will rain at least once in 30 days. So I would describe that as likely. Question 3. List the sample space for each of the following. To list a sample space, the correct way to do it is to start with an S for sample space equals, and then you open some big curly brackets and you list the possible outcomes inside. So for a coin, you could get a head or a tail, and then you close the bracket up. Question 4 is a bit different. It says state how many, if I want a number, how many possible results are there if you do the following experiment. So the first experiment is that we have a raffle and there are 200 tickets sold. So how many possible results are there? 200, because each ticket would be a different result. I'm going to do D as well. So how many different results are there when you roll a dice? This is a normal standard dice, so there would be 6. Question 5. Write down the sample space for the following as an ordered list. So this is sample space question again. S for sample space equals big funny brackets. And I want the outcomes when an 8-sided dice is rolled. So let's do them in order. 1, 2, 3, 4, 5, 6, 7, and 8 for the 8 sides, and then close the bracket. Question 6. A day of the week is to be randomly chosen for a special event. List all of the possible outcomes. So that's a sample space. And now the possible days of the week start from Sunday, and we go through each day: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Then part B says list all of the weekend outcomes. The weekend outcomes are the Sunday and the Saturday. Part C, find the probability, so this P stands for probability, that a day is on the weekend. When you're finding a probability, you usually write the answer as a fraction unless it says otherwise. The number on the bottom is the total number of possibilities. So in a week, there is 7 different days you can have in a week. On the top, you want the number of favorable outcomes, and for this one, we want the days on the weekend. So Saturday and Sunday, or 2, there are 2 favorable outcomes for the top. Question 7. On a shelf, there are 15 books. There are 4 novels, 3 science books, 3 mathematics books, and 5 history books. List all of the possible outcomes. There's a sample space. So sample space is equal to the types of things that we have are novels. We also have science books, and we have maths books, and we have history books. In the next section, I want to find some probabilities. So the first one says probability of getting a science book. There were 15 books on this shelf, and we want to know how many science ones there are. There were 3 science books, so 3 out of 15. And then if possible, you should simplify your fractions. So dividing top and bottom by 3, we get 1 over 5. Or you can do that on your calculator. Question 8. There are 3 free dinners to be given away on any one of the 7 nights of the week. If I chose a night at random, what is the probability that I will be there on a night where there is free dinners given out? So it's a wordy question. Don't let that throw you off. All it's saying is that there are 7 days in the week, and there is a 3 in 7 chance that they'll be given away free dinners on that particular night that I choose to go in. Now, you see a couple of crossed off questions here. You can do them if you like, but those kinds of questions are not going to be on your exam. So let's skip over to question 12. At a shoe stall, there are 12 pairs of shoes, 2 pairs of sandals, 3 pairs of thongs, 1 pair of slippers, 2 pairs of boots, and 4 pairs of sneakers. If a customer selects 1 pair of shoes, find the probability of boots. There were 2 pairs of boots, so 2 will go on the top, out of the total, which was 12 shoes that we were told from the beginning. Dividing top and bottom by 2, that will simplify to 1 over 6. And you can do the rest of those ones in the same way. Question 13. A card is chosen from a standard deck. There are 52 cards in a standard deck. Find the probability for each of the following. Selecting an ace. In a deck, there are 4 aces out of the 42 cards. And then you simplify that down. So you can remember, you can use your calculator if you like. So 4 out of 52 simplifies to 1 out of 13. Question 14. In a sports store, there are 15 balls. There are 6 tennis balls, 1 medicine ball, 3 cricket balls, 4 soccer balls, and 1 football. If a teacher selects 1 at random, find the probability of a soccer ball. There were 4 soccer balls out of the 15. So 4 out of 15, which doesn't simplify, so that's it. Well, maybe we should do one of these ones down here that says or. If I want the probability of a soccer or a cricket ball, I would add the soccer with the 3 cricket balls, so that's a total of 7 out of the 15. Okay, next worksheet, the more describing questions. Describe the likelihood of the following events using the words impossible, unlikely, even chance, likely, or certain. So Thursday will be the day after Wednesday. I'm pretty sure that that is certain to happen. Okay, so we've done those questions before. You can fill in the rest of those ones. Question 2, match each description. We have the descriptions down here, and we want to match it with the spinner. So the first one says blue, red, and green are equally likely. That means that the pieces have to be the same size, which would be E. So next to that one, you'd write E is the correct spinner for that question. Part B says red, green, and blue both, sorry, it's just red and green, sorry. Red and green both have an even chance, so there's actually no blue at all. And if you look at C, you can see half the pieces are red and half the pieces are green, so that's an even chance. So that will be C. See if you can match the rest of those spinners to the descriptions. Question 3. A fair six-sided dice is rolled. List the sample space. S for sample space equals, and the possible outcomes are 1, 2, 3, 4, 5, and 6. Then I want to find a probability. Find the probability of rolling a 5. There is 1 5 out of the 6 outcomes. So there's my probability. Part C, find the probability of rolling an odd number. The odd numbers are 1, 3, and 5. So there are 3 of those out of 6, but that would simplify to a half. Find the probability of rolling a number greater than 2. Greater than 2 does not include the 2, so it's the 3, 4, 5, and 6, which is 4 out of the 6 outcomes, which simplifies to 2 out of 3. Question 5. When playing with a spinner with the numbers 1 to 4 on it, the following numbers come up. So this is an experimental probability because theoretically, if these were all equal size pieces on our spinner, then they should all be equally likely. But experimentally, we have a list of results here of what actually happened when the spinner was spun. Now, you would hope that if you did this experiment enough times that it would get closer to the theoretical probability of a 1 in 4 chance, say, of getting a 4. But let's have a look at what we've got with the results that we've been given. It says, what is the experimental probability of getting a 4? So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 experiments that have been done there. And we have 1, 2, 3 4s. So it's a 3 out of 10 chance. Part B says, what is the experimental probability of getting a number less than 3? Less than 3 does not include the 3, so we're looking for 1s and 2s. So there are 4 of those out of the 10, which simplifies to 2/5. And question C, based on this experiment, how many times would you expect to get a 4 if you spin 100 times? So we had a formula for finding the expected number of items, and it is that you find the probability of getting a 4, which we already worked out up here. It's 3 out of 10. And you multiply it by the number of trials, which is 100. So probability times the number of trials was our formula, and that equals 30 times. Okay, so there's a few more crossed out questions in here. These kind of tables are the ones that you need to know. This is a two-way table where you're comparing two different things. So in this one, we're comparing people who like maths and people who like English. And you'll see on each axis, one is the maths and one is the English. And it's always the opposite of each other. So we have like, dislike. Sometimes it's plays or doesn't play, or but they're always opposites. Now, this question has some of the data filled in for us. Sometimes you need to do that yourself from the bit of text that you've been given. But because we have these numbers in here already, as long as we have two numbers in a line, we can work out a third one. So for example, the 8 and the 17, we could find this missing one in between because the 8 plus the blank must equal the 17, the total at the end. So let's subtract them. 17 take away 8 means that this needs to be a 9. I could also do 28 take away 17, which would give me an 11 in there. I could do 11 take away the 5, which would give 6 for this one. And then I could go down the columns. 8 plus 6 is 14. And 9 plus 5 is also 14, and you could double check that 14 and 14 does make 28, so it seems to be working. Now in part B, I want to transfer that information into a Venn diagram. For a Venn diagram, you want to start with a rectangle, and inside that you want to have two overlapping circles. The two circles represent the two things that we're comparing. We are talking about people who like maths and English. So they're my two circles. The four numbers that need to go into that Venn diagram are the first four numbers in the table. So the 8 is people who like English and like math. That is the overlapping section of your Venn diagram, so the 8 goes in the center there. The 6 is people who like like English, but don't like math. So we don't want them in the math circle, we want them over here in the English circle because they like English. So let's put 6 over there. The 9 is people who like math but dislike English, so that will go over here. And the 5 are people that don't like math or English. They go outside the two circles in the bottom corner of the rectangle. Okay, so that was a quick run through of probability. Now you need to go back and finish all the blanks.